This is the solution video for section 8.1, problem number 4. All right, so it says for problems 3 through 8, find the area of the region bounded by each set of graphs. So I have y equals x cubed minus x, and then y equals 0. All right, so first of all, y equals x cubed minus x. I need to figure out what this graph looks like. All right, so I'm going to set it equal to 0 and factor. So I've got x times x squared minus 1. And so there's x equals 0 or x squared plus 1, sorry, minus 1 equals 0. And so x equals 0 or x equals plus or minus 1. So this is a cubic polynomial with a leading coefficient of 1 with zeros at 0, 1, and negative 1. All right, so what does that mean? Well, that means it looks like this, right? It has its left end behavior down, its right end behavior up, and it goes through each of those zeros, right? And then I have y equals 0, right? So what is y equals 0? Well, y equals 0 is the x-axis, right? The horizontal line. And so I have two regions here that I want to find the area of, right? That are bounded, right? So the first one is I have the region that goes from -1 to 0, and then I have the region that goes from 0 to 1, all right? Now, what you need to realize is in the first integral, right, I'm going to integrate from -1 to 0. Now, I'm going to take the upper boundary of this region, which is the x cubed minus x. So x cubed minus x. And then I'm going to subtract the lower boundary, which is 0, right? And I'm going to integrate that with respect to x. But then I'm going to integrate from 0 to 1. And now you see the upper boundary of that region is 0. And then I'm going to subtract the x cubed minus x. And so it's important that you remember that there is a parenthesis around the x cubed minus x so that you distribute the negative. Now, parenthesis here wouldn't really matter, right? All right, so now I'm going to integrate. I get x to the fourth over 4 minus x squared over 2. And then obviously the 0 goes away, and I'm going to evaluate from -1 to 0. Then I'm going to add. It ends up being the same integral, right? Well, I have the negative in front, right? So I distribute, I get negative x to the fourth over 4, and then it becomes plus x squared over 2, right? And then evaluate from 0 to 1. All right, so I'm going to evaluate with 0. So I get 0 to the fourth over 4 minus 0 squared over 2, right? Then minus -1 to the fourth over 4 minus -1 squared over 2, right? All of that is the first integral, then plus the second integral. So I've got the negative, then I've got 1 to the fourth over 4 plus 1 squared over 2, then minus, and then I've got negative 0 to the fourth over 4 plus 0 squared over 2. All right, so now obviously the parts with 0 go away. So now I have minus, and I have 1 to the -1 to the fourth. So that's just positive 1/4. So I'm subtracting it because of the negative in front. And then here, -1 squared is positive 1/2, but then I'm subtracting a negative, so it becomes a plus. All right, then I've got this whole part is 0, right? So now I've got -1 to the fourth. So that would be minus a 1/4, and then plus a 1/2, right? And so I have -1/4, -1/4. So that's -2/4. So that's actually -1/2. And then I have a +1/2 and then a +1/2. So obviously our answer is 1/2. So that is problem number 4.